So I had asked you to fill out a table for the following limit and then answer the following limit. So I plug in 1.99 into this function. What do you get? Negative 100. And what about when you plug in negative 1.999? $10,000. Okay, so as x approaches 2 from the right, this would be from the right, correct? What are we doing? The next one would be 100,000. Then after that, it would be a million. Then I mean, we go up. So what's it approaching as x approaches 2? Infinity. Everyone agree with that? Because it just keeps getting bigger. The more zeros I tack on, the bigger I get. What about the other way? So what does that mean for the double-sided limit? Does not exist. Well, if you had done this limit analytically, would you agree you would have gotten a number over 0? Which means you have a vertical asymptote, which means the double-sided limits automatically does not exist. We know that answer. The question is, how could I have come up with these two answers without using a calculator? Would you agree if I have a vertical asymptote, the limit is either approaching positive or negative infinity from the left or the right? So I have a 50-50 chance, right? It's either infinity, so I can guess and get one of them. Or I can do a little better than guess. I could think about what would happen if I plug in a number really close to 2, but to the right of it, right? Would you agree that's going to give me a positive number? That's really all I need to know. Would you agree with that? And if I pick a number to the left of 2, I'm going to get a negative number. So remember the absolute value problems, how you knew the answer was either 1 or negative 1 from the left and right. You just had to decide if it was positive or negative. On vertical asymptotes, we know the answer is either infinity or negative infinity on the left and right. I just have to decide which one. So that's what we're going to be doing today, is limits at vertical asymptotes. We did those yesterday. All right, so limits as x approaches a vertical asymptote. If you use substitution, which you should always do first, you get a number or a non-zero number over a 0. Then you know the graph has a vertical asymptote, and the limit will either equal positive infinity, negative infinity, or does not exist, depending on left or right. To determine the answer, you must substitute in a number on either side of the vertical asymptote into the equation to decide which one you're approaching. Again, we don't need a calculator to do that because all we need to decide is whether it's positive or negative. So we're going to do some examples. Okay, step 1, what do we always do when we see a limit, no matter what the limit is? Plug it in. So I plug in 3. What do I get if I plug in 3? A number over 0, which lets me know I have a vertical asymptote. Double-sided, I'm going to write does not exist. From the left. Okay, so, and what am I going to do to decide that? Good. Plug in like 2.9. Something close to 3 on the left. All I need to know, because I know this is either positive or negative infinity, right? So if I plug in 2.9, a number to the left of 3, all I need to know is if this number is going to be positive or negative. And it will be negative. Does everyone agree? Okay, before I move on, does anyone not know why all I need to know is positive or negative? Or in general, are there any questions? before we go on. Okay, let's look at the next one. What's a number to the right of 3? 3.01. Again, I'm going to always hesitate to pick something too far away because what if x minus 4 is also a factor on the bottom? If I go too far away, it may cause issues. So I'm going to stay close. And if I stay close, we get a positive number, 3.01. Now, 4 would work on this problem, but sometimes if you get too far away, it might mess you up. So, positive infinity. Any questions about that one? How do I know that answer? So number over 0, can't trap infinity for a double-sided limit. Good math teacher is always going to say does not exist. We'll talk about another answer that is also acceptable on the AP exam for this problem. I don't like it, but the AP exam will accept it, and I'll show you that in a second. 0 from the left. What is a number to the left of 0? Negative 0.1. What happens when you square negative 0.1? It becomes positive, but then I've got another negative sitting out here, so what am I approaching? What about this one? It's also negative infinity, isn't it? Does everyone agree with that? AP will accept negative infinity there. I don't like it. They'll take it, though. Why will they accept it? Because the left and right hand limits are negative infinity, and so they'll say. So, if you're ever on an AP exam multiple choice, and D and E is not an option, but negative infinity is, then pick the negative infinity. D and E is an option, it's a better option. They should never be both an option at the same time, because AP should know better. But if they do put it at the same time, then D and E is the correct answer, because you cannot remember the formal definition of a limit that you don't technically have to know, and that's why AP is a little more lenient on this than a college calculus professor would be. It's because they don't make you know the formal definition of a limit, so understanding the trapping of the limit in the box, they give you a little more leniency on that. So just mental note, they'll take either one. The best answer is does not exist. Okay? And I think it's an easier answer, don't you? Because then you don't even have to think about the other two limits to get it. It's just vertical asymptote does not exist. Okay, try these. Notice none of them are left or right. They are all just double-sided. Yes. What did the limits last night all ask you to find? The limit as x approaches what? That's when you think horizontal asymptotes, because that's where horizontal asymptotes happen. Does that make sense? Yes, after we finish learning all the different types of limits, they will then go all together at the same time, where you'll have to choose what to do and when. It's not that bad. You got this. Yeah, I don't know about that. I think we're a couple days ago. That had waited. Maybe. I don't know about yesterday, but we've been on limits for a full week. Week and a day.
Yeah, but I
Good.
can't use cut.
Okay. Number 1, top left. Does not exist. How do you know? Plug it in. Does not exist. What about this one? Does not exist. Now, they would accept, what is it? Negative infinity on this one. Because from both sides you're going to approach the same thing, so they would accept that. But that's not going to be my default answer there. I'm going to put does not exist and only answer the other question if I must from the left and the right. How do you know? Negative 4 squared is 16 plus 8, right? Everyone agree? 16 plus 8. What is 16 plus 8? 24. And what's 24 minus 8?
16. 3/8.
Yep. Negative 6 over positive 16.
Oh,
Is that right?
yeah.
So Abby asked me, am I going to have to tell the difference between these? Absolutely. What did you do first on that one? What do you always do first on the limit? Plug it in. If you don't get a number over 0, it's not a vertical asymptote, it's something else. Well, what about this one? What do I get? I get 0 on top. What do I get on bottom? 0 over negative 8, which means 0. So 0 on top, but not on bottom, is a number, and it's 0. It's the 0 on the bottom that causes a vertical asymptote. Any questions about that? Okay, that is all we have for today. I am going to hand you a worksheet, and you'll probably finish it in class. I'm also going to go ahead and hand out a limit review packet that you can start picking at if you would like. You don't have, there's not even an official due date on it. I'm just going to give it to you because you may finish your homework in class and have nothing else to do. So it will be a limit review that we work on next week.